As I said, in just a second, we are going to take some notes that will help us for our upcoming quiz on Monday. In this important information section, I'm going to talk about a lot of the vocab words that we've talked about in Chapter 8. You will want to know this for different vocab sections on our quiz and test coming up. All right, so let's look at the first one. Blank is an entire group of people or objects. Who remembers what that one was? Caleb, what was that? A population. That is correct. Then we talked about sometimes we take a small part of the population. Halen, what is that? Sample. It is a sample. We also talked about two different kinds of samples. The first one I want you to write down is an unbiased sample. We learned that it is good to be unbiased because in order for it to be unbiased, it has to be two things. Does anyone remember what those two things are? Christopher?
Large and random.
It needs to be a large sample and a random sample. And that's why an unbiased sample is a good one. Which means the next one, a biased sample, that's the one that's not so good because it is not representative of a population. Because of that, it shows us that one or more parts are favored. Now I want you to underline this next word, average. Does anyone remember the name for the average of the data set? Not the median. What is it? The mean. Okay, mean is another name for average. I want you to underline these two words, middle number. Guys, what is the middle number of a data set? That is the median. Next up, the range is the difference between the highest and the lowest numbers of a data set. Another phrase that we've used, I want you to write this on red pen off to the right, is the IQR. The interquartile range is another word for the range. Finally, we talked about box and whisker plots, and we found out that some are skewed and some are not skewed. In this case, a box and whisker plot is skewed when one whisker appears way blank than the other. What is that?
Bigger.
Bigger or longer. Okay, so it has one short whisker and then it has one long whisker. All right, next up we're going to determine if the sample is biased or if it is unbiased. Guys, which one is the good one, biased or unbiased? Unbiased. I want you just to put a little smiley face near unbiased, which means biased is going to be the sad smiley face, which is bad, it's no good. So here's problem number one. You want to estimate the number of students in a high school who ride a bus to school. You ask 50 students during their outdoor school activity. Here's how you can tell if something is biased or unbiased. You look at who you're asking. Who did we decide to ask about this survey? 50 high school students, and where were they?
At school, outside.
At school, outside. They were all hanging out outside at this outdoor activity they had. So what you want to ask yourself, is this a large sample? Yes or no?
Yes.
Yeah, 50 is a good large sample. Did we ask them at random?
Yes.
Yeah, they were all outside hanging out, and I just went randomly up to a bunch of different people. So this would be considered unbiased. Correct. This is a good survey, or this is a good sample. Let's go to the next one. Same idea, determine if it's biased or unbiased. You want to estimate the number of people in Jacksonville who enjoy shopping at the St. John's Town Center. So you decide to survey 20 people in Miami. Give me thumbs up if you think this is unbiased. Give me thumbs down if you think this is biased. I'm seeing a lot of thumbs down. Why do you guys say, someone explain to me why you think this would be a biased conclusion? Caleb.
About 1,000 people will enter Florida nearly every month or year, I don't know when, but they asked 20 people out of the many people that are in Miami.
They asked 20 people. Is that large?
No.
Next up, he focused on, they asked people in Miami. Guys, do you think the people in Miami have been to Jacksonville to shop at our St. John's Town Center? Maybe, but
No.
probably not. Okay, so this does not seem to make sense, which means this would be a biased opinion. The people in Miami are probably all going to say, meh, no, I don't really like shopping there because I don't shop there, okay? So this would be a biased opinion. It's only focusing on the people in Miami. Now we're going to go on to something else. Valid versus unvalid. Whenever you have these, and it's asking you if something's valid or not valid. Valid is it correct? Basically, did they do their math correct? Or is it not valid? They did their math wrong. So let's look at problem 3. You want to determine the number of students in your school who have been to see a movie at an epic theater. Raise your hand if you have been to an epic theater before. How many of you have been to AMC?
Oh, yeah.
Or Regal Cinemas? Okay, so there's a bunch of different ones. This one, they are focusing on those who have been to an epic theater. You go out and you survey 40 students at random. Okay, so that's a decent survey amount, and you randomly asked them. 35 say, yes, I've been to an epic theater. And 5 say, nope, I have not. You conclude that, I want you guys to circle 15%. We're trying to figure out, is that 15% correct or is it not correct? Is it valid or is it not valid? You conclude that 15% of the students in your school have not seen a movie at Epic. I want us to always focus on who we are looking for. In this case, underline this for me. Students in your school who have not seen a movie at Epic. I want you to double underline the word not. So in this case, we are figuring out favorable divided by the total. Favorable, if you remember, is what we're looking for. We are looking for people who what? Have not been to Epic. According to your survey, how many people did you find have not been to an Epic theater? 5. So I am focusing on that number right there. 5. I don't care right now about that number 35. Okay, favorable, as I said, is what we're looking for. Over total. How many total students did you survey? 40. Okay, we always know whenever we have a fraction bar, that means 2. Guys, what's 5 divided by 40? Okay, those of you who said 8, you divided the bottom by the top. 40 divided by 5. You have to take the top number, 0.125. Let's turn that into a percent. When you do that, what do you get?
12.5%. Are we rounding?
It never says anything about rounding, so we're just going to stick with 12.5% is how many people have not been to an Epic theater. Is this a truthful conclusion? No, why not?
Because they got 15%.
They said it was 15%, but we figured out it was what percent? 12.5. So class, is this valid or not valid?
Not valid.
It's not valid. It was close, but it is not valid. That means it is not truthful. I want you guys to try to do problem 4 on your own. It's going to be done just like that. Okay, so number 4 says you want to determine how many people like the pizza in the lunchroom. So you survey 75 people at random coming out of chapel. 60 of them say, I do like it, and 15 people say, I don't like it. You conclude that, and this is what we're trying to figure out, is this valid or not? 80% of the people you asked, and this is what I'm looking for, do like the pizza in the lunchroom. Let's start with favorable over total. Guys, favorable is what I'm looking for. I am looking for people who do like the pizza. How many are favorable? Out of how many total? 75. Anson, when you do that, what do you get? Kaylin, can you help him out?
If 0.8 and you change it to 80%.
You are correct. That is exactly what we wanted it to be. So we would say, yes, this was a valid statement. All right, the next one. Which sample is better for making an estimate? So here's what we're looking for. You estimate the number of families in your town with 1 or more children. What would be better? Sample A, a random sample of 10 families that live near your home, or sample B, a random sample of 10 families that live in your town. Why do you think B would be better?
Because it's random and not like
If I'm trying to figure out the families in my town,
it says living in your town.
you're right. So I would want to go to people in my town, not just those who live near my house. Those who live near my house, maybe they have a bunch of kids too because it's a family-friendly neighborhood, okay? So you've got to make sure that you are going to the most random parts and not just favoring one specific section. All right, for the next problem, You and your 4 friends want to know how many students in your school prefer country music. Back in lesson 8.2, we focused on what kind of music? Pop music. Today we're talking country, okay? There's 900 students in your school. Each person in the group randomly surveys 30 students. The table shows the results. Here's what I want you guys to do, please. Take your red pen and circle just the country people, which means we do not care about the other part right now. I don't care about pop. I don't care about rock. I don't care about rap. So we're not focusing on the other ones. For this problem, we are focusing on the country music people. There's a formula we need, and I want you guys to write this formula to the right of your box. I don't have enough room, so I'm going to put it right here. Favorable divided by the total equals n. N is just what we're looking for, divided by the population. All right, so for sample A, it says to use the sample to make one estimate for the mean number of students in your school that prefer country music. Let's focus right now on you. Guys, when you went out, this is where we're going to find this, you found how many people that like country music? 10. I want more people to respond to me. Guys, how many people like country music you found out? 10 out of how many? How many people did you go and ask?
30.
It says right here you surveyed 30 people. So 10 out of 30 equals n over the population. Anson, how many people were in the population total? 900. So guys, if our whole goal right now is to get from this number to that number, I have to figure out how to get from a 30 to a 900. If you do that, you just take the bigger number and divide it by the smaller number, and what do you get? 30. So I'm going to multiply 30 times 30 to get 900, which means I also have to multiply the top by 30. When I do that, what do I get? 300. I want you guys to look down underneath it where you see the word you in the box, and I want you to put 300 there. Okay? Now we're going to move on to friend A. We're going to do it the same exact way. Gerard, when you see friend A, how many people did friend A find that like country music? 2 out of how many? Out of 30 equals n over the population. How many were in our population? 900. We're going to use the same missing link as we did before. How do I get from 30 to 900, Gerard? Multiply by 30. What you do to the bottom, you also need to do to the top. So friend A estimates that how many people in the school like country music? 60. Who would like to help me with friend B? Christopher, how would I do friend B?
2 over 30 equals n over 100. Probably 9.
Okay, how many did friend B get? 8. There we go. That's what we're going to focus on. 8 over 30 equals n over 900. What was our missing link? How do I get from a 30 to a 900? Times by 30. We'll also multiply the top by 30, and what do you get? $240. Okay.
Paul, is Heather Clendon?
Okay, let's look at friend C. Does anybody notice anything about friend C? Zariana, what do you notice? It's the same as B. So do you think there is any point in us doing all that work?
Yeah.
No. What's the answer going to be, guys?
Same as B.
240.
It's also going to be 240, the same as B. Who would like to do friend D for me? Zion, go ahead.
Friend D has 15 out of 30 people, and then to get to 930, you have to multiply 30 by 30 and do the same at the top, which is over.
Very good. Okay, so he got 450. Okay, so now what it asks us, now that we have all of that, we want to put our data set in order from least to greatest. I want you guys to look at your box that you have right here. You're going to put this directly underneath the box. There's just a small little spot in your notes. And we're going to put it in order from least to greatest. Guys, what's the smallest number we found there? 60. I want you guys to put that underneath the first box. The next number, what's the next smallest number? 240. And the next one? 240 again. Remember, even if you have the same number twice, you've got to keep them both there in your data set. Just the girls, what's my next number?
300.
And boys, what's the final number? 450. This will now give us the opportunity to answer question A. Coming back to what question A says right here. Use each sample to make one estimate for the mean number of students in your school that prefer country music. Do you guys remember how to find the mean or how to find the average?
Add them up and then divide them by the number of years.
You are correct. So we are going to take all of those numbers right there and we are going to add them together.
All of those numbers?
Okay, so you're going to put 60 plus 240 plus 240 plus 300 plus 450. Is there anyone who added those all up? Zion?
240 plus 240.
What did you get, Zion?
1,290.
Very good. Everyone write that down. 1,290. Guys, is that my answer?
No, because
No. Okay, Christopher, how do I find the mean now that I know that added together?
Divided by 5.
You are correct. We divide it by 5 because there were 5 different numbers up here in our data set. When you do that, Adam, what do you get? Very good. 258. Guys, what are the units attached to that? 258 students, okay? We were guessing or estimating how many students we believe in your school prefer country music. Now, we just took that sample. We did not figure it out on our own because we really don't have time to go and ask all 900 students. So that's why we did this sample. All right, so now we're going to go on to sample B. It says use the sample to describe the variation of the estimate. So you can see we've still got our numbers over here from least to greatest. We are trying to find the center, or in this case, the median. Kaylin, what is the median of that data set? Very good, okay, because all it is the number in the middle. So 240, and what would the units be attached to that? Students, very good. Does anybody remember how to find the variation or how to find the range of this data set right here? Justice, what should I do? Subtract the biggest number from the smallest number. So write this down. The biggest number was 450. We're going to subtract the smallest number, which was 60. And Justice, what's that answer? 390 what? Students. Very good. Any questions about how to find the median and the variation? All right, good job. All right, problem number 7. An administrator randomly asks 48 middle school students if they are in favor of the new dress code. 12 of them say they are. There are 900 middle school students at the school. Estimate the number of students in the school who are in favor of the new dress code. I want you to write this down. We're writing favorable divided by the total equals n divided by the population. I want you to try to do this with your partner and see if you guys can come up with what the correct answer is. All right, let's see how you guys did. Guys, favorable. How many people were in favor of the new dress code? Everyone. 12. Out of how many did they ask?
940. I don't know.
They only asked 48. Equals n over the population. How many were in the population? 900. Did anyone do this with mental math?
Yes.
How many of you would say you did it with cross products? Okay, you could have done either way. Mental math I enjoy better because it's much faster. So you're trying to figure out how to get from a 12 to an n, which means you have to figure out how to get from a 48 To a 900. So take the bigger number and divide it by the smaller number. When you do that, what's the missing link?
18.75.
Okay, so I've got to multiply. I know that's not a whole number, but we can still use it. Also multiply by 18.75 on the top. When you do that, class, what do you get? 225 what? Remember, you always need units attached. All right, question number 8. You want to know the mean or the average number of hours students in the band practice each week. 5 students were asked at each school, and 4 different schools are represented. So let's focus. We're going to focus first on school A. So in order to find the mean or the average, we have to add up how many hours they did and divide it by the number of students that we asked. So first off, I want you guys to add up the number of hours for school A. How many total hours did school A practice? 55. We're going to divide that by the number of students we asked, which was 5. So 55 divided by 5 is 11. We're going to put that 11 down here where it says sample A because that came from school A. Now let's focus on school B. I want you guys to add up how many number of hours that they practiced for the week. Zion, did you get it? How many did they practice? 50 divided by 5, and what was their average? 10. You're going to put that down here where it says sample B because that's for school B. Now let's go on to school C. Zariana, what should I do to find the average number of hours they practiced at school C?
Add the numbers out.
Add the numbers?
Yeah.
Okay, go ahead and add them for me and tell me what you get. All right, 45. Divide that by the number of students you asked. So what is the average for them? 9 is correct. Who would like to do sample D? Let me have Kaylin. Go ahead. When you add up all those hours, what do you get?
And you divide it by 5 and you get 11.
You are correct. Okay, so it looks like they did the same as sample A. Now it asks me to find the mean of all the schools. Can someone explain to me how I would find that? Zion, what should I do?
Add up all of the means that you got.
Very good. We're going to add up all of these means that we got. Zion, when you add those together, what do you get?
46.
Not 46. Double check.
46 and 9.
Gerard, what did you get? 41, okay? Is that the mean?
No.
What do I have to divide by?
4.
4. I'm dividing by the number of schools. And this will tell us the number of hours that all of them averaged. When you do that, Adam, what'd you get?
10.25%.
Okay, 10.25 what? Not percent. Look to see what we're looking for. What are we trying to average? The mean number of hours. Very good. Okay, so the final 4 questions are going to be about box and whisker plots. First things first, what are the measures of center? Guys, remind me again, what's another word for measures of center? Median. I want you to take your notes, get that red pen, and write that off to the side so that you remember as you're studying, a measure of center is the median. Anson, what is the measure of center, or what is the median on shelter A? 7, that is correct. Because remember, you're just looking for whatever that middle number is right there in the middle of your box. Justice, what is the median or the measure of center for data B? 8. Correct, because it's that dot that's right there in the middle of the second set. Let's go on to the next one. Measures of variation. Do you guys remember another name for variation? The IQR, the interquartile range. So remember, you're going to take the upper quartile and subtract the lower quartile, and that will give you the IQR, or that will give you the variation. Caleb, how would I do that? So what is the highest and the lowest?
Is it like the whisker?
We're not looking at the whisker, we're only focusing on the box.
9 and 5.
9 minus 5 equals? 4 is correct. Who would like to do data B? Let me have Christopher, go ahead.
9 minus 5 equals 4.
We are on data or shelter B.
Oh. 11 minus 7 equals 4.
You are correct. All right, so we've got 2 questions left, 11 and 12. The first question says, which data set is more likely to have a value of 10? Raise your hand if you think it's data A. Raise your hand if you think it's data B. Excellent, all right, it is, because here is 10, and we're going to come up and we will land right there in data set B. One final question for today. Which data set is more likely to contain a value that differs from the center by 3? Guys, help me out. What does it mean to differ from the center?
So subtract,
Add or
like move.
Okay, to like move, it means to be different by 3. Okay, let's look at this one. Here's the center. How much is that one different?
2.
2. How much is that way different?
2.
Okay, so we know it's not that. Let's look at this one. How much is that way different?
1.
1. How about this way?
Is
3. So what's the answer? It is data B. Okay? If you understand this, you're going to do fantastic on our quiz coming up on Monday.